So welcome all of you. Thank you for spending your time with us. And this is the third of our three-part international workshop on fish, fisheries, and carbon. So today we're going to talk about the social impacts of carbon and fish and fisheries and how they interact. And like Rebecca said, we're co-hosting this together. So we'll be coming and going, right, to moderate and get us going. So yeah, I move on to the next slide. Like I said, this is the third part, and we started this week on March 6th, on Monday. We started with the base of all of this. You have to understand the fish contribution to carbon flux. And if you're going to talk about this, that is a good place to start, right? I had a series of wonderful talks. Some of you, I'm sure, were there and listened to this. Then on Wednesday, that was yesterday, we had the second one where a connection was made between fishery impacts on the carbon sink, right? So how do our fishing impact the carbon sink? So that is another important aspect of this. And then today we're going to take this and talk about societal impacts. When you manage your fish stocks to protect carbon, what does it mean for people, for society, and for sustainability, and all sorts of things? And we have a nice group of people to help us do this. So this is how we'll be spending our time. We are now starting very soon. This introduction, after that, there will be a poll to just have a feel of those who have joined us and what this means for you. And then we go into the main session, and you have 5 plenary speakers who will talk about different aspects of societal impacts. And then we do the lightning talks, and there will be 3 of them. So in all, we have 5 talks. In all, we have 8 talks. And by the time we finish, linking to day 1 and day 2, I believe that we will have a good picture of where we are when it comes to carbon, fisheries, and fish. Then we take a break and come back and do the breakout interactive discussion. And this is I followed this for the 2 days, and it's very interesting. That's when we hear from all of you who have joined us. We share, we learn, we interact. And so that's the plan. That's the plan for us today. And then in the breakout session, the items we'll be talking about, we'll be discussing gaps in knowledge and prioritization of research to fill these gaps. And we'll also talk about available tools and data, again, for filling the knowledge gaps. From data, we talk about knowledge gaps and how could fisheries management help to limit the impacts of fishing on the ocean carbon cycle, which is a crucial question for this session, actually. So we'll get going very soon. And at this point, I don't know, Beck, you want to add anything, maybe a quick comment, and then we go on to the polling.
Sure. Hi, everybody. Good morning. Yeah, I'm Rebecca Hubbard from Our Fish, and I'm really excited to be here. It's a really exciting workshop to have from people all over the world. Really great to see people from all of the hemispheres and all of the time zones. Thank you so much for making time in your day to join us. Yeah, I'll leave it at that, and I look forward to the conversations. Over to you, Heather.
So Heather will take us through, right? Yeah.
Yes. Hi, everybody. We're really excited. So if for those who don't know me, I'm Heather Benway. I manage the Ocean Carbon and Biogeochemistry, or OCB, project office, and we are based at the Woods Hole Oceanographic. We're in the East Coast of the US time zone here. I have just dropped a link into the chat for a Menti poll. This is really just an introductory get to know who's joining from where poll. Just want to get a sense of what kind of global representation we have here today, and then there'll be a second follow-up question. And feel free to elaborate in the chat too, if you feel wherever you're joining from is not adequately represented in the options.
Mhm.
Fantastic. All right, I'm getting ready to go to the next question. In a short word or phrase, tell us why you're here. What made you want to come to this workshop? This session, even if you want to get more specific. This looks great. So I will stop sharing now so we can get on, but you can feel free to keep taking the poll, and we will be archiving the results of the poll. So you'll be able to have access to those later. But thank you very much and welcome.
So, and I just want to make a special note now to say thank you to Heather and to May, who are the brilliant technology angels behind us. So thank you so much. So first of all, we're going to start with the 5 plenary presentations, and then we'll move on to the lightning talks. So to begin with the plenary talks, we have the best person to start, and that is Professor Rashid Sumaila, who is University Killam Professor and Canada Research Chair in Interdisciplinary Ocean and Fisheries Economics at the Institute for Oceans and Fisheries and the School of Public Policy and Global Affairs at UBC. Thank you so much, Rashid. Take it away.
Thank you so much, Beck, and each one of us will have 10 minutes to talk. So if you see me talking fast, that is the reason, all right? So here, I'm just going to very quickly, simply make a case for why we should take carbon into consideration when we manage our fisheries, when we manage our oceans. And the first point is that really, we need to talk what we need to apply. We need to apply all the theory. We need to practice what the theory of economics says, you know. And what I see is that when you look at the real practice, whether in terms of actual valuation and the use of the valuation, we are not really walking the talk, because economic theory calls for a comprehensive compilation of all the values from whatever you are looking at. All the values, the population, the people put on that thing should be taken into account. So we talk about the total economic value, right? And the theory stipulates that the total economic value should include, among other things, not just what you catch and sell in the market values, but also the non-market values. So there you go, right? So it's not only the fish you catch and sell that gives us value. There are other values from the fish. Think carbon here as we go. The theory says it's not only the direct use value, not the value that you directly take, you know, but also the other indirect values that are inherent in this case, in the ocean, right? And you have to talk about the option value because, you know, what do we know at the moment? We don't know everything, no way, far from everything. So there may be values in the ocean that we can't even think about. Think of carbon. A few years back, nobody was talking about carbon values of fish carbon, and today is very topical. So economists say just because of that, you should think about your valuation very carefully, because something may just pop up. And you saw that in all the high seas treaty negotiation, they spend more time on genetic resources than even on the fish, right? Because people are anticipating. You should take that into account. Existence value. The animals there have a right to be there by themselves, not because they give us value. And then because value, we've got to think of the future generations. So these are all the reasons why we need to take carbon, but not only carbon, all the other benefits, values, ecosystem services that we get from the ocean. Now, when you look at, this is not easy. It's easier said in theory than in practice. Challenges to valuation. There are many. Difficulty in determining all the things people actually value in any given time, right? Because, like I said, something new may just pop up. And some things are simply invaluable. Many people would tell, why do you even try to value this, right? there is uncertainty, there is misinformation, untruths, the post-truth world, all those things are there as challenges, right? And then when the rubber hits the road, certain values are given more weight. For example, current versus future benefits. The politicians, right? There's election coming next year, all that matters is now. And that can be problematic, right? And you have to be very careful of that. Private versus societal benefit. What comes to you as a fisher versus the general benefit from carbon that goes to society at large. When the rubber hits the road, the private benefits runs over this. And salmon for us to eat versus salmon for the seals, because the seals are part of the natural system. When you talk about food security, we all talk about people, but how about the food security of the seal? So you need to do comprehensive evaluation, that is what. But do we do it? This is data, it's a bit dated, but I think it's still quite true. When we look at the literature, environmental economics, only about 1% of the valuation talk anything other than the market value. So you see that we're already skewed. This is the valuation, not even the practice, which means the practice is even weaker. We don't take care of things like carbon. So because of all these reasons, we need to bring carbon and all the other ecosystem services we know about and value, or some of us value. And that is the reason. And when you do that, this is a very simple schematic I just did. If you just look at the market values and you say, should we protect carbon in the ocean, and you do the calculations, this is the kind of thing you are likely to see. If you don't take carbon in, you are going to see more fish value because you are not integrating that in your analysis. But if you do, this is the picture you actually get, because the value of carbon could be, and in many instances, is many times higher than the fish value, like we demonstrated in this paper with Alex Rogers, where we showed that at any given year, if you take the carbon sequestration value of high seas creatures, animals, and compare it to the fish value that year, 10 times. So that's another reason why we should take carbon into consideration. This is a picture that I'm showing here. Generally, we talk about the impact of climate change on the animals and the fisheries, but this is about also what the fisheries do to carbon and therefore to climate change, which again comes back and hits the fish and life in the ocean and the fisheries and the people. And this is what this is all about, these 3 sessions on all the work on carbon, not just looking unidirectional, but also the other way. And we have a special issue that from Frontiers, which we have scientists, some of them presenting here, that have talked about that. Now, I'll use this to kind of articulate some of these things. This is essentially a picture demonstration overfishing in 3 different ways, in my view. First of all, there's the fishing down marine food web. We take the big and valuable fish first, we truncate the ecosystem and make it more vulnerable, everything being equal, right? That's one. And then we take too much fish. That's another thing. And we impact the habitat, which can release carbon, which can make life more difficult for the fish, and therefore you won't have more biomass as you would in a properly managed habitat system. And all of this feed into the carbon value of the fish, and also can feed into climate change impacts in so many ways, as some of the literature have shown. So that's that. And at the end of it, the societal impacts actually come down to what is working through my head so much. This is how to make the ocean and the fish continue to give us benefit through time. And that is the infinity concept. We can say infinity ocean also, infinity biodiversity. Essentially, how do you ensure the fish are there forever, the animals, the ecosystem, the biodiversity. And if we're able to do that by passing a healthy system to our children, they can also do that and their grandchildren. And we can continue to have these benefits, and then show that fish is actually more valuable than diamond or oil and gas or gold, if you really do this comprehensively by taking into account the carbon value in what you do. Thank you very much for your attention, and I stop here and pass it on to the next one.
Thanks, Rashid. I'll introduce the next speaker so you can take a breath.
Thank
So
you.
as Heather pointed out as well, because we have 5 longer talks, we're just going to answer questions mostly in the chat. We might have a little bit of time if the presenters are very short to answer one live. So next up we have Maartje Oostdijk. Maartje is a postdoctoral fellow at the University of Iceland and holds a PhD in fisheries modelling, a double degree between University of Iceland and Stockholm. She currently works on management of mixed fisheries under climate change and governance options. Maartje, over to you. Thank you.
Thank you, Beck. Thank you all for all the organizing as well, all the organizers. I'm presenting some work today that I did while affiliated at World Maritime University, and I did this work with many collaborators who are all on this slide on the governance of open ocean and fish carbon, the ecosystem functions that Rashid was just talking about. And to resonate what Rashid was saying, like in fishery science, we are very used to talk about the impacts of climate change on fish stocks and not so much the other way around. This is a topic that fish contribution to carbon cycling has been studied somewhat in the 80s, but it's being recent years have seen a sort of uptake in this science and much better and fuller picture and quantification of their contributions. So fish store, of course, carbon in their bodies, but they also, some of them actively transport carbon from the surface to depth. They feed at surface and they escape predation, for instance, at depth, and in that way contribute massively to the ocean biological pump. So should we govern these ecosystem services? And if so, how should we do that? That was sort of our question at the outset. And we were also wondering if governance of these ecosystem services is already a topic in the global climate and biodiversity agreements that are currently exist or are negotiated. And to answer these questions, at least give some indication, we conducted several expert interviews and we did a text mining analysis of 10 sets of global policy frameworks. We constructed a timeline on how this topic has evolved in the scientific and science policy interface, as well as we asked the experts what they think are promising or likely avenues for the governance of these carbon sequestration ecosystem services. So the ocean is a topic, of course, that should feature highly in the climate agenda because the ocean is a massive carbon sink. And it's extremely important for climate regulation, but it hasn't always featured so highly in climate change negotiations. This has changed in the past decade or more, for instance, by NGOs pushing for more attention for the ocean, as well as scientists, and organizing, for instance, ocean action days at conferences of parties within the UNFCCC. In this decade, there have also been emerging ways to account for the ecosystem services of wetlands. Coastal wetlands have been included in that as well. For instance, mangrove areas. And in more recent years, researchers have also asked the question, fish also contribute to carbon sequestration. Should these creatures also be protected for their role in the ecosystem, including their carbon sequestration role? Analysis showed a somewhat very surprising Ocean and climate were mentioned in documents together. That did happen. But for instance, topics like coastal blue carbon or ocean carbon featured very little in any of the agreements. And we also constructed a focus factor of these documents, which basically synthesizes the set of keywords and and a higher score shows that the text focuses more on biodiversity or on climate. And the different agreements that are focused on biodiversity, of course, scored higher on biodiversity. But some of them also scored relatively higher on climate change, while the climate change documents scored less high on biodiversity. We also computed the ocean carbon focus factor, and there we found that the Convention for Migratory Species and the Convention for Regulation of Whaling scored relatively high, and they actually made explicit mentions of the role of whales in carbon cycling. So to conclude this, we found that key actors promoted ocean carbon by bridging the science policy interface, and they also provided scientific input to negotiations. And we found that the actors largely focused on the Univ CCC, but we've also found some opposition in some of the interviewees of bringing this topic of fish carbon into the climate negotiation spheres or climate agreement spheres, because they found that quantification is still in its very, very early stages. And this topic could be of interest for the United Nations Fisheries Stock Agreement, for instance, within the ecosystem-based approach.
Yeah, so we have Dr. Andrew Pershing, who is Director of Climate Science at Climate Central. And he focuses on expanding public awareness and understanding of climate science across disciplines, something highly needed in my view. So thank you for joining us and for doing this. Andrew, over to you.
So thank you. It's really great to be here. This has been a fantastic series of workshops, and I just really want to say thank you to all of the organizers for pulling this together. It's just been such a great week of learning for me. So I'm going to present some results from a paper that Jonathan Falciani published last year on optimizing fisheries for blue carbon management. This came out in Limnology and Oceanography. Jonathan was a research experience for undergraduate student who worked with myself and Maria Gregoritou at the Gulf of Maine Research Institute, and he's now at DTU Aqua finishing up a Fulbright scholarship. So you will be seeing more from Jonathan in the future. So we're obviously here to talk about fish. And one of the things that's really interesting to me from the point of view of somebody who's been very interested in the ocean and biogeochemistry and carbon and things like that is that one of the cool things about fish is that we actually interact with them, right? We look to fish for food, right? We look to for fish for multiple values, as Rashid said, but that means that we have control. We fish stocks and we can choose to fish them less. We have other stocks that maybe we haven't fished that you could choose to fish more. So we actually have levers that we can pull, which is something that we don't have for other carbon pools in the ocean, like phytoplankton. Of course, we're here to talk about carbon, right? As a key goal that emerges from our concern over climate change. And then ecosystem health is another one of these more kind of total valuation ideas that fish play a role, right? They are food for other organisms, and they're an inherent part of the ecosystem, and they have functions beyond carbon and for their value for us. And so I'm going to talk about these three trade-offs using the model that Jonathan presented. So the model is based on MISR, which is a size spectrum model. So we're going to have biomass plotted against size. We have a fixed, in our experiment, just a fixed flux of energy that comes into our fishery system. You can think of that as the amount of primary productivity, and it's fixed through time. That gives us then a size spectrum. with the abundance of fish at different sizes. And from that size spectrum, we also have loss terms that emerge, right? Because they're density dependent. They depend on how much and how big and how that carbon is distributed across the spectrum. And that includes metabolism and natural mortality. And then, of course, we're going to fish them, right? We're really interested in understanding what happens when we fish this spectrum, especially as we change how we fish it. So the experimental setup is that we're going to lock the incoming primary productivity. So we're going to have the same amount of carbon potential in the ecosystem. And then we're going to play games with fishing. And really what we're going to do is just mash the buttons on our video game controller and explore a wide range of parameter spaces on how you could fish across the spectrum. So both intensity and focus, right? Whether you're fishing small or large or mixing around. And then we're going to look at things like biomass and yield as our main response variables. So I'm going to plot biomass versus yield here, and everything's normalized to the unfished biomass. So that's what 1 means. So we're going to start with, I'm going to lay out then how our 3 goals play out. So the first thing we'll do, right, we mash the buttons, we get all of these realizations within this parameter space. And the first thing you see is that, surprise, surprise, the more yield you get, the lower the biomass is, right? Fishing kills fish. So that's not really a surprise, but it gives us kind of our first set of trade-offs. So if we are interested in maximizing the carbon stored in fish, and I forgot to mention, we're really focused on the biomass, right? The carbon that's stored in the living fish tissues. I'll mention fluxes in a little bit, but so the standing stock of carbon in fish is maximized if you fish less. Our valuation, right? The human values are maximized potentially if you fish more. And then you have the ecosystem goals that are going to align with the carbon goals. And so we would want to fish less because it would leave more fish in the ecosystem for penguins and birds and dolphins. So now what I'm going to do is we're going to try to understand the variance across these strategies. So what we're going to do is we're going to lock the fishing goal. So what we'll do is just look at what happens as we say that we're just going to pick a particular yield that we want out of the system, and then try to understand what are the different ways that we could get that yield. And if we look across the strategies, we see that that all of the red dots that are above that black line, we have actually more big fish, and all of the blue dots, we have more small fish. We've changed the size spectrum. And that's because it emerges from our fishing strategies that if we want to maximize carbon for a given amount of yield, we should fish on smaller fish and allow the big fish to remain and pool up. And the same thing goes for the ecosystem goal. And this big fish story is something that, I've been thinking about quite a bit, including in some of our whale work, right? Whales and big animals do amazing things. They have this high metabolic efficiency. So from my 2010 paper, we just did this kind of numeric experiment and said, okay, if you remove 1 blue whale from the Southern Ocean ecosystem, that's going to free up a certain amount of krill every year. That one 92-ton blue whale could be replaced by 7 minke whales, right, who would eat that same amount of krill, or 1,800 Adelie penguins. But if you total it up, right, you can see 1 whale, right, 7 minkies, 1,800 penguins, right, you increasing penguins, but the amount of biomass, if just multiplied by the weights, the system is actually storing much less biomass if you turn it into a penguin system from a blue whale system. And that extra carbon potentially is now going to be in the atmosphere. It has to go somewhere. Okay, so back to our story. The other thing that we were really interested in is to really kind of focus on the ecosystem goal. This dashed line area here is what we call the conservation subset. And what we did was we said, we want to exclude all strategies that led to extirpations of one of the fish stocks in the model. And so some of these red dots up here, while we can get a great amount of yield and we can store more carbon, right, potentially 10-15% more, we actually do that with a very engineered ecosystem. So imagine like cutting down a forest and planting a monoculture of trees, right? You could have an engineered system that would maximize the carbon goal. So if we want to, so for the ecosystem goals here, we're going to say that we want to fish carefully. So I want to talk very quickly about flux. This was mentioned by one of the reviewers on our paper. This was like the best interaction I've ever had with a reviewer on a paper. And I'm so grateful to whoever this was. And so just very quickly talk about flux. So here's our biomass size spectrum for, imagine one of the systems where we have high biomass, so a red dot. And now here's one with a blue dot where we've reduced the biomass. And we've done that by manipulating the fishing. So we've shifted from fishing on the small to fishing on the large, and we have fewer fish. If we look at our flux terms, we have this biomass flux term that changes. We actually have more flux out of the system in the high biomass situation and less flux in the low biomass situation. And that's potentially because then the flux is potentially going to predators, right? So if we are concerned about penguins, we might have more of them up here. So that's an ecosystem goal. But we also potentially have a carbon goal in that flux could be natural mortality that goes into deadfall carbon, which could be exported from the system. But there's also a metabolism term, and this comes basically from the fact that we're looking at a steady state model. And so we can figure out the size of that metabolism arrow. We have lower community metabolism in the high biomass situation. And that could potentially mean lower egestion, lower production of fecal pellets, which is a different export pathway that potentially is lower in this situation than in this one, due to the fact that we have potentially fewer small fish or more small fish down here. So just some very quick conclusions. There's the export conclusions on the right. Carbon management is ecosystem management. So I hope I'm not stealing Rebecca's thunder. I saw her title, but they really line up very nicely. There is space to achieve multiple goals. For our study, we focused on carbon stored in living fish because it's easy to account for. But the flux terms are going to be a lot more complicated. And that's a lot of what we've heard this week. And that's in part because we have this potential trade-off between metabolism, which could lead to CO2 to the atmosphere, metabolism, which could relate in this model to egestion, or to the production of fish that then lead to natural mortality and deadfall export. And all of that is going to vary with size, and all of that is going to vary with space. And the spatial distribution is going to matter a lot. If you have an ecosystem on the shelf, you're probably have less potential for export than if you're looking at like the Peruvian upwelling system. So thank you, and I will yield the floor.
Thank you so much, Andrew. That was really super fascinating. And I don't mind you stealing the title of my presentation, because I would hope that it's the title of everybody's presentation today. So next up, we have anybody who wants to remember to put questions into the chat, and the speakers can answer them as we go. And of course, once we get into the breakout groups, there'll be plenty of opportunity for conversation around these issues. So next up, we have.
Hi, thank you very much for the opportunity to speak in this really very interesting, exciting panel. I think the series of talk over the 3 workshops is really interconnected and really complement with one another. I think my talk will build really nicely on the previous 2 talks, particularly Andrew's talk about the interactions between fishings, climate change, and various socio-economic objectives associated with fisheries and fisheries management. Next slide, please. So, in the context of the status of fish stocks, I think you have heard that from that in previous workshops, that many of the fish stocks in the world are not in a good status. For example, even in some of the developed countries, regions, waters, like in Canada, many of the fish stocks are estimated to be overexploited. Similarly, in European waters, it is similar case, and the numbers vary between different methods of assessment. But in general, many substantial amount of fish stocks are overexploited. And there's also a gradient, often a north-south gradient too, where for example, in Europe, the northern stock seems to be more well managed compared to those in the south, such as in the Mediterranean. Next slide, please. So that brings up in the broader context that the fish stocks have multiple benefits that are contributing to the society. Like we talk about carbon, but then also food, livelihood, and culture. And at the same time, it is facing multiple threats from climate change, ocean warming, deoxygenation, ocean acidifications, as well as other changes associated with climate change. But then the demand for fish for various human values, also human benefits, also have an impact on fish stocks. So what we are seeing is a complex interactions between the natural and human systems, and that will be quite a nexus approach that look at how we can manage the oceans for food, for climate, and for biodiversity as well. Next slide, please. So in this remaining presentations, we will be exploring some of these nexus questions, and particularly trying to use that to inform some of the opportunities as well as challenges in ocean governance to support both climate mitigations, food security, and biodiversity conservation. Can you press a few button, please? This is yeah. So we use a existing modeling approach that look at thousands of fish stocks in the world, including invertebrates, and then simulate changes in their distributions, ecophysiology, abundance, and potential fisheries catches around the world in different ocean basins and different ocean regions. Next slide, please. We also link that to how that will play out in different scenarios of social and economic changes, and as well as climate change. Next button, please. So in this couple of slides, I want to just take the example of the European marine regions as an example to illustrate some of this complexity, and then I will quickly mention broadly in some of the more intense considerations of a trade-off in other regions of the world oceans. So in this particular example, we look at fish stocks in 15 European marine regions, and we look at how fishing interact with different climate change scenario or global warming scenario that affects ocean conditions, that affect ocean temperature, but then also oxygens, primary production, and things like that. So with that, even with a supposedly good fisheries management that aim for maximizing fisheries production at maximum sustainable yield, we see that the biomass will be, or these fish stocks will decrease really substantially, below 50%. In this exercise, 50% is supposed to be the target. So with climate change, it will, even with good targeted fisheries management, it will reduce lower than the target, and the reduction is more in high climate change, weak carbon mitigation scenarios, up and down to 29% of the biomass level in its pre-industrial unexploited level. Next slide, please. And of course, if fishing's intensity increase to an overexploited level, we further reduce its biomass to a really low level that is of really conservation concerns. At that level, some of the species, vulnerable species, can face risk, local extinction risk as well. And as Andrew mentioned, some of the measure of the amount of biomass is also relates to the amount of contributions to carbon mitigations through fish productions, etc., which has been discussed in previous talks in the past few days as well. Next slide, please. It is only until that there's a much more conservation fisheries focused management with subfishing that is considerably lower than that target for maximum sustainable yield that we could rebuild the fish biomass to a level that is at least at target of current fisheries management. So it really highlight that we need to consider a sustainable fisheries management to help support rebuilding of biomass that would then help with carbon mitigation. But then we also need to consider how climate change would be affecting or impacting these fish stocks, and that we need to adjust the target for fisheries management to accommodate that, which in most of the case will be a more conservation focused fisheries rebuilding strategies and targets. Next slide, please. So before I go to this example, I just also want to highlight that there are also examples, particularly in tropical waters, where the fish stocks and fisheries are much more sensitive to climate change. For example, in the Indo-Pacific regions, the decrease in biomass is almost double than those in European waters under climate change. And those regions are also most dependent on fish and fisheries for food, livelihood, as well as culture. So that creates a more intense trade-off. On one hand, we want to have less fishings to rebuild more biomass so that it can contribute to more carbon capture. But then at the same time, there's also a big demand for the utilizations of the provision service from the fish stocks for food, for culture, for food and for livelihood, as well as to support as cultural value. So that trade-off will be more intense, particularly when climate change becomes more and more intensive. And that really need to be accounted for when we think about planning for ocean governance, for food, climate, and biodiversity. But then there are also examples where this trade-off is much more easy to resolve, where it can even be having a co-benefit, a win-win solutions. One of those examples is in the open oceans. We know that these large pelagic fisheries also contribute to carbon mitigations by capturing the carbon, and then their body is sinking to the water. This is based on a study that a PhD student in Montpellier we estimated the amount of biomass that could sink to the sea bottom based on the existing fish stocks and how much overfishing reduce the capacity of these large pelagic fish in contributing to those carbon mitigations. Next slide, please. Next slide, please. So what it finds is that many of the fish stocks that are really heavily exploited are these large pelagic fish stocks that are heavily exploited, and that the biggest biomass are in tropical oceans, open oceans, where only a handful of high sea fisheries are operating, particularly those by developing countries such as Japan, South Korea, Spain, and USA. The small-scale fisheries only contribute a small proportions of those of the exploitations of those fish stocks. Next slide, please. Yeah, next slide, please. Next slide, please. So and based on works such as Rashid, it shows that those fisheries in those open oceans, tropical waters where fishing for these large pelagics often are heavily subsidized through those industrial countries, high sea fishing fleets. And so in many cases, if they eliminate those what Rashid called the harmful fishery subsidies, those fisheries would become unprofitable to operate. So what it means is that if we operate the principle of sustainable fisheries management by reducing or eliminating these harmful subsidies, we could essentially help to reduce fishing pressures on those large pelagic fish stocks and help those that are overexploited to rebuild, and thus contribute to high carbon emission, high carbon mitigations from those large pelagic fish stocks, as well as more conservation, better conservation outcomes for these fish stocks, and also support coastal fisheries, where when these fish stocks migrate back to their coastal states, the small-scale fisheries can also benefit from the increase in abundance. So this is an example of how sustainable fisheries can create these win-win solutions for carbon, for climate, food, and biodiversity as well. Next slide, please. So in summary, I think there is a lot of potential of restoring carbon sequestration potential of both the shelf sea as well as the open oceans by sustainable fisheries. One of the low-hanging fruit is that we remove harmful fisheries particularly on the high sea, on distant water fishing fleets through the industrialized countries, and it also relied on effective fisheries management. But then it needs to account for some of the trade-off that are associated with particularly for those vulnerable groups and fisheries that are heavily dependent on fisheries for food, livelihood, and culture. And that overall rebuilding overexploited fish stocks is a good thing for all these different objectives, both to support food security, for support climate mitigations, and biodiversity conservation. Thank you very much.
Thank you very much, William. So we're now going to our last talk, and I have the privilege of introducing again Beck. You're going to wrap it up for us, yeah. And she's already introduced herself, so you know who Beck is. Beck is, there's one piece of information I just want to share. Beck is in transition. She's taking up a position as director of the High Seas Alliance. Congratulations, Beck. This is really cool to see you already in action after the treaty was signed. So over to you. Wrap it up for us.
Thank you, Rashid. Indeed, I am going to be working on the high seas, and I think that this is even an exciting space as well in terms of the management of fisheries and carbon in the high seas. As you know, some of those presentations and papers have shown that actually that's where there's really great opportunity to have a big impact on fishing carbon. So my presentation is a little bit higher level. I don't do the very, very detailed modeling that some of you guys have done, but really looking at the people aspects and the fisheries management aspects. So so I always like to start with the fact that ocean is a life giver. Excuse me, I'm just going to close the door because someone just started playing music in my in my house at the same time that I began presenting. It's always typical. The ocean is, as we all know, the life giver, but I really just want to focus on this, particularly with the subject of our presentation today. It's the source of life on Earth. It's obviously critical to climate, as you all know very well. It's absorbed all of that excess heat that we've produced, and as has been discussed, and William, I think, focused really nicely on, it's incredibly important for food, livelihoods, and well-being. So, and the way that we look at it is that fish are the lifeblood of that life giver. So they're incredibly important. And I think, as Andrew was also mentioning, the functioning ecosystems and the ability of those ecosystems and the ocean to provide ecosystem services. So we really started working on this issue a couple of years ago and focusing on the role of fishing and impact of fishing on climate change, because most of the science we were seeing was about the impact of climate change on fisheries instead of the other way around. So it's really exciting to be seeing so much science and conversation around management policy and science of the impact of fisheries or potential of fisheries to contribute to climate mitigation. So I think you all know about the importance of the biological pump, and there's been many presentations in the other workshops on this. But the way that we really like to look at it is that those fish and marine life are carbon engineers in the biological pump, and the importance of those and maintaining those populations as part of the biological pump. What we have really focused on is the impact of fishing, as I was saying, on the biological pump. So when we look at overfishing or destructive fishing, as I think Rashid gave a really good overview on that, we know that it's the biggest impact on ocean biodiversity. We know that it results in declining catches for people to discuss today. And I think it's highly linked to subsidies, as Rashid mentioned. You know, this is just a slide on the EU and its use of fuel. So the European fishing fleet, or the EU fishing fleet, based on their annual economic report, you know, they burn around 2.3 billion litres of fuel a year, produce around 7.3 million tonnes of carbon dioxide, and that is all propped up by fuel tax subsidies. And so not only are we encouraging or promoting overfishing by paying for fuel or subsidizing fuel costs, we're also actually driving pollution. And that's because obviously we lower the operating costs, and we know fuel is very, very expensive for fishing, and it's a major contributor, but also it obviously drives overfishing because some of the most destructive fishing fleets actually use the most fuel. So essentially, I've skipped one. So essentially, what we can see is if we focus on good fisheries management, or as Andrew said, good ocean management, we can deliver good carbon management. And I think this is just a bit of a wrap up of what many of the other presenters have talked about in terms of, you know, the various benefits that we can have on food, livelihoods, ecosystem services, and obviously CO2 emissions and carbon sequestration. So in terms of what we can do to improve or minimize the societal impacts from fishing's impact on climate, there is a number of really straightforward fisheries management tools that we can activate. So as discussed, we can set fishing limits below maximum yield and instead even try to rebuild the populations so that they're much more resilient. We can actually, one thing that we're really interested in is assessing and managing both the climate and ecosystem impacts. So really, you know, it's a lot of chat here about how do we manage those and assess all of those carbon impacts and the ecosystem impacts. How can we turn ecosystem-based management into climate and ecosystem-based management and consider ecosystem services in that analysis as well? That's a really big challenge for all of you that can make those those systems, because I certainly can't, but that's a challenge that we've put out there. We can also allocate access to the fisheries resource to incentivize a transition to those lower impact or low carbon fishing. So, you know, put criteria on access to fishing quota. So where fishing fleets have lower carbon footprint, or where they leave more large fish in the sea, etc., you know, they get a higher access to the fishery, which will help to transition those fleets to a new and more sustainable, both environmentally, but socially and economically as well, set up. And then, of course, stop subsidizing fuel tax. I mean, we just have to always say this, but we have so many potentials for alternative supports that would actually support financial supports that would actually enable and conserve a socially and environmentally fishing industry that are much more effective, useful and positive than fuel subsidies and other harmful subsidies. And I'll just leave it at that. Thanks, Rashid. Actually, I might just continue because I think Rashid has to step out very, very temporarily. So moving right along, I haven't even seen the chat, so I'm sorry if there's any questions in there. I'll have a look at those shortly. But the next part of our session is 3 lightning talks. And so we've got 3 short talks from Nathalie Hilmi, Phil Kithil and Debbi Pedreschi. So I'll ask Heather or May if they can help with those presentations. Perfect. Nathalie, are you here? I can't see you, but I'm sure you're here somewhere.
Hello.
Hi, great. Nathalie, if you would like to take it away. Thank you very much.
Hello, everybody. The ocean moderates global warming by absorbing about 93% of the excess heat and about 26% of the excess of CO2 from the atmosphere. Next slide, please. The term blue carbon refers to the carbon captured in coastal and marine ecosystems. These include coastal vegetated ecosystems, as well as the open ocean from the surface to the deep sea. Nature-based solutions can help manage human impacts and tackle climate change to preserve ecosystems, their functions, and the services they provide to human well-being. Next slide, please. You can see here the ecosystem services by the fish and the fisheries, and the different categories of ecosystem services. Regarding the ecosystem services of fish, the most important one are the provisioning services. We can evaluate them, and you can see on this table some figures for aquaculture and wild caught fish. For regulatory services, we can say that fish are also important in terms of food web dynamics regulation, nutrient recycling, the maintenance of sediment processes, and the maintenance of genetic biodiversity. The blue carbon from the fish would have technically been sequestered since the majority of dead fish sinks to the bottom. Therefore, fish possesses a reverse regulating service. You can see also the supporting services and the cultural services. Culturally speaking, fishes can be seen as a production and curing activity, and mostly refers to the materials, techniques, and symbolism in the artisanal fisheries to some communities. In a nutshell, these examples can show the wide variety of market-based and non-market valuation techniques available in order to estimate the value of ecosystem services according to their types. These valuations always depend on context where they are implemented. Thank you.
Thanks, Nathalie. Phil?
Yeah, thank you. Phil Kithil, I'm founder and CEO of Ocean-Based Climate Solutions, Inc. and the parent company at Motion Inc., which was founded in 2006. Ocean-based climate solutions spun out in 2018. And we've been doing artificial upwelling from the start. And a really great paper just came out. I want to summarize it here. Artificial Upwelling, a Refined Narrative by Maartje and Andreas Aschlies and Walter Covey from Geomar, Kithil, a refined narrative just published last month at Geophysical Research Letters. On the left, I've added in a sketch of how much carbon dioxide must be removed to reach 300 parts per million, which is close to pre-industrial, slightly above atmospheric level of CO2. And overlaid that on the CMIP5 graph showing parts per million on the left axis and of course the years on the bottom axis. And as you can see, the blue line, RCP 4.5, which is more or less where we are today, I believe, we need to remove over around 2,000 gigatons of CO2 to get back to 300 ppm. And then if we miss that and go up to RCP 6, which is on the order of 3,000 gigatons, it's just a much steeper hill to climb. And heaven help if we stay on RCP 8.5, don't even want to talk about that. But on the right is a key slide from the paper showing the combination of the solubility effect, solubility pump, and the biological carbon pump in gigatons of carbon removed over the next 80 years. If you put pumps such as what we offer out in the open ocean, widely spread across wherever it makes sense. And so the model assumes a 1 centimeter per day upwelling rate and a 1 pump per square kilometer. Our upwelling rate is actually greater, so we can do it with about 1 pump for every 2.7 kilometers and reach these total levels of carbon dioxide removed over 80 years, depending on the RCP level. So as you can see, the red solubility pump is a smaller percentage under today's arena, but becomes a bigger percentage the worse it gets, the higher atmospheric CO2 goes. And then as we come down, hopefully, the solubility pump actually offsets the biological carbon pump. So I view that as a soft landing. The pumps are out there working, absorbing, but the solubility offsets some of that as you get closer down to 300. But I do want to then talk about, next slide, please, the art of artificial upwelling. So we've been at this, as I said, since 2005. Here is one of our pumps in the open ocean, actually off Santa Cruz Island, California, Los Angeles area. That's about 15 feet or 5 meters long. It's holding a tube, in this case, 200 meters deep with a 1-ton bottom weight and a 1-weight valve. And this fits in a shipping container. So this is the biggest pump that we can make that is economic. The flow rate, we did a test in November in the Canary Islands with Geomar. We got 3,000 cubic meters per hour flow rate, and that gives us the 1 pump per 2.7 kilometers would meet the modeling output that's shown in the Jercott paper. These pumps self-deploy. The tube that is reaching down to the deep is a fabric material, heavyweight, rugged fabric, so it's spooled up around the buoy and it self-deploys when you offload it off the boat. And it's ultimately removable. There's a recovery line, you can lift it up and get it back up. Those are the green checks.
Sorry, if I could just jump in, you've got 1 minute left.
Okay, great, almost done. What we're still working on is the MRV, the measurement, recording, and verification. We can put sensors on the pump in the water just beneath the buoy and actually measure the solubility effects. The biological effects are much more difficult because they're downstream, they're diluted, they're a long-term effect, the phytoplankton to food chain to fish and so on. And the pump life, we're still working on that. This is a one-time upfront cost, so we have to amortize that over a number of years. Next slide, please. And the final part of artificial upwelling is the social license. And as Brad Act from Ocean Business, without social license, you have nothing. We are positioning this as not so much sequestering CO2 in the ocean, because that is seen as an environmental bad under many circumstances, and but rather that this is a way to grow more fish, restore ocean ecosystems. That we think is viewed as an economic good and also creating jobs, a political good. So that is our direction regarding the social license aspect. And I'll leave it at that. And thank you very much.
Thanks, Phil. Debbi?
Hi, everyone. Can you hear me? Yes. Okay, great. Hi, my name is Debbi Pedreschi. I work at the Marine Institute in Ireland, and thank you very, very much for giving me the opportunity to speak to you today. I apologize if some of you were, well, I expect many of you were at the session yesterday. You may have seen something similar from my colleague Mary Weiss, who was invited to speak in that session on this topic. But for those of you who haven't, I'm here to talk on behalf of the OceanICU project, which is working to improve carbon understanding for healthy and resilient ocean and sustainable blue economy. In that project, I am one of the leads, along with Mary Weiss and Kate Larkin of Seascape Belgium, connecting OceanICU to society, and I'm leading on integrating the industrial and ENGO needs and understanding into the work that we do in that project. Next slide, please. So it's a Horizon Europe project that just kicked off. Well, we had our kickoff meeting last month. We have over 30 partners and we're running up until 2027. And there's about 13 million euros going into this project. So it is a large scale project that is aiming to try and define the current state of the carbon cycle and assess future climate driven change, get a better understanding of the biological carbon pump and the key processes relevant to industrial effects such as fishing and mining that contribute to this or have the potential to contribute to it. We want to translate this knowledge into tools that allow ocean users, licensors, policymakers, whoever is interested, essentially to estimate carbon impacts and to be able to use this in a variety of methods. We want to also estimate the industrial future trajectories. So what is the development that's going to happen within fishing, mining and other offshore activities to estimate the future impacts on the ocean carbon cycle as well. So there's an awful lot of modeling work going on. We've got a nice little graphic you can see there that's been inspired by the Lutz graphic that's been shared quite a bit. And yeah, so next slide, please. So what I'm here to do today is to ask you guys to get involved or to share your knowledge with us. We've been attending this week, so we're learning a lot about what's been going on in other avenues, but it's always great to work together and collaborate rather than try and do things separately in silos. So if you're interested in this, do get in touch. But what we are actively recruiting for at the moment are stakeholders that have an interest in climate, fisheries, marine extraction, areas beyond national jurisdiction, marine policy. All of these are things that we are working actively on. If you need to know more about the ocean carbon cycle to help with decision-making, policy-making, licensing, and so on, then do get in touch. We're also looking at ways to try and integrate stakeholder knowledge. So we're looking at, what are the futures for the ocean? What are the trends that we expect? And what are the management and policy needs, and what type of tools and outputs would be useful for the various stakeholders to come out of this project. And we really do want to get as much input as we can at the early stages so that we can tailor all of the outputs from this project and make them as useful as possible so they can be uptake and actually applied in the real world. So if you are interested in joining us, please do have a look at the link there or scan the QR code. If you have any questions, please feel for me or my colleagues, please feel free to send me an email there. I'll also put the link into the chat. And if you think that it's not exactly relevant for you, but that you have networks or colleagues that would be interested in it, please do feel free. And in fact, I would highly encourage you to share that link along your networks and through your Twitter and social media and so on. We would be very grateful for it. Thank you very much.
Brilliant. Thanks, Debbie. It feels like that project is going to bring all of these elements together into a beautiful new world. So thank you, everybody, for the presentations until now. Okay, so we're back on the hour or the half hour, depending which time zone you're in. If everybody can switch on their videos, it will make this next session a whole lot more interactive and interesting. Hopefully you have enough bandwidth to do that. The next half of the workshop is really where we get to workshopping, and I think is, considering how many incredible experts and brains we have in the room, it will be a really interesting session. So we encourage you all to participate fully. In the next session, we're going to look at, we're really going to break down the knowledge that we have available to consider the societal impacts when managing fish stocks to protect carbon. And then we're going to look at, how we can address any gaps, what's available for doing that, and really focusing a lot, because of the topic of this particular workshop, on how we transition to fisheries management, a fisheries management of the future that really incorporates protection of those fish stocks and an energy transition, whilst also ensuring and maintaining all of those important ecosystem services for people, and ensuring resilient societies and functioning economies, because unfortunately we all work in an economy as well. Brilliant. How did everybody go? Would we?
Yeah. Yeah. It's Maartje, we're together.
We're just in shock from being kicked out. Okay. So I think we were thinking about if we could have a very quick look at the Jamboards from some of the different groups. I was deeply involved in the conversation that we were having in our group, so I didn't look at some of the others, but I can just quickly open some of them and then maybe share a screen so that people can have a little look. Oh, that's cool.
We are not seeing, only you are seeing. That's cool.
No, okay, I'm going to share my screen.
Yeah, okay, good.
Okay, I'm not sure if you can only see, can you see group 1? Yeah, okay.
Group 1, yeah.
So I just randomly opened group 1. It looks nice and organized. Available tools and data sources. There's some really good and thorough listing of data sources. I like the idea of game theory.
Game theory, yeah.
Really interested by that, maybe because I don't know enough about it. I also noticed that these guys had an axis, which was really exciting for me. I think if I shift to a different group, you won't be able to see it based on the experience from before. But I like putting a price on carbon. That's reflective a little bit of what we did in session 4. Can you see group 4 now, or still group 1? Group 4? Great. So we had smash capitalism. Can you see that?
I can't see the group 4. Or is it up there? Yeah, it's group 4. Yeah.
Yeah.
Okay.
So we just went straight to the point, and we're going to smash capitalism. That was thanks to Angela. She's incredibly
Are you
expert
sure?
at-
Are you sure?
Yeah, Rashid, you can tell us how that's going to work later, because you're the economist. And so just quickly flicking into group 3. Can you see group 3? Well,
Yeah.
Wow, group 3 was incredibly prolific, and I'm very impressed. Coastal blue carbon, pushback on considering ocean carbon. How do you design fish carbon management to support climate justice? Like
Yeah, that's a cool one. Yeah.
Needs to be considered when managing for carbon. That was a really interesting conversation we had about trade-offs. Yeah, there we go. There will be trade-offs, and how do we value and assess those trade-offs? Designing carbon market mechanisms. Looks like there's an incredibly rich amount of information here. I don't think we can go into every single one of them.
Yeah.
Did I skip group 2? I'll just have a quick look at group 2 so we can look at how systematized all of our groups are. And here we are. I was hoping that a group would use different colored sticky notes. And I think that this is potentially the peak where we're going to finish on review of the groups. So I don't know how the color code works, but it looks good. Available tools, IPCC reports, financial incentives, illuminate hidden harvests. Be very interested.
Hidden harvest, yeah.
That is.
Small scale stuff, right? Hidden harvest.
Okay. And then how we transition. Let's hold decision makers accountable. Let's end on that. So there's heaps of amazing information there, which we will be pulling together and summarizing all of these word clouds and Jamboards and producing a report and creating recordings that everybody will be sharing or that we will be sharing in the next few weeks. Rashid, is there anything else that you want to add on how we're going to be on next steps?
Yeah, one thing I could add is the Q&A. There were some really good questions, and I haven't been able to answer to them. So we'll look at your questions that you put in the Q&A and chat and try to respond to them and send to participants. Yeah.
Great. And so Heather has put an exit poll, or
We've asked this question of all 3 of the sessions, and it's been an interesting mix of responses, but this isn't just about the organizers following up on outcomes of the workshop. We want everybody to engage on this. So this also, you know, we'll be looking at these polls and thinking about outcomes that create an arc from, you know, looking at the science, the scientific studies that are looking at fish carbon fluxes and drawing that arc all the way across to what we talked about today was, you know, getting into some of the management aspects of fisheries and how to maximize carbon uptake.
Fantastic. Thank you everybody so much for sharing your expertise and really engaging in this workshop. As I said, we're going to review all of the information and we will pull things together and post the recordings on the workshop website. And we'll send an email out to all of the participants to the whole series of workshops, pointing people to the resulting information and reports. But it would also, as Heather suggested, be really great for people to think about for all of you to think about which parts of those activities going forward you'd like to be active in, because we really, as the co-hosts and organizers, really want to build this community of people going forward who are active on driving this agenda, because there's quite a long way to go as we
think about what would facilitate this for you. If you're trying to gather forces to write a proposal about something, what is it that you need to develop those networks and connect with the right people?
Yeah, and there were a number of really good questions and research issues that were raised. Somebody was saying, hey, how much will it cost to buy out the fishing industry? We could make analysis of this, or if not buy out the whole thing, a portion of it, whatever, so yes, we'll look at your comments and really develop things there.
Great.
Very good. I learned that some people, the Europeans, it's about over 2 a.m. or something. So thank you so much for doing this. This is serious stuff. To stay. Yeah, you see, Stephen is, and actually Stephen said something. He said a few years ago, there was such few people who are thinking about it, that he was very impressed on the numbers of people who actually came over the 3 days. And so, yeah, that's a good comment. Thank you for that.
And thank you to the people who started this conversation all those years ago.
Yes.
It's so exciting to be building on that work. So maybe we'll wrap it up here. I think we went 5 minutes over time. Sorry about that, but thank you so much for all of your input. Have a good sleep or a good day if you're in the Southern Hemisphere like me for once. It's not the middle of the night.
Yeah. Thank you so much, everybody. Bye-bye. Yeah.
Thanks a lot, everybody.
Thank you, everybody.
Thank you. Bye-bye.
Thank you.